buffering. This is the concept which transfers the data from the secondary storage to a temporary storage provided by OS for any process in main memory. The data is prefetched from the secondary storage and put into the temporary storage called as buffer in the main memory, so that when the data request was raised by the CPU, the data is transferred to certain frames in the main memory and the data is readily available for the CPU. There are two categories how the data is buffered. One is block oriented and another one is stream oriented. In block oriented, the input output device transfers the data from the secondary storage to the buffer in a block-wise manner. A block is nothing but a contiguous stream of bytes, that is a fixed size data is called as a block. So the data is transferred block by block from secondary storage to the buffer, and again from the buffer it transfers block by block to the CPU. Some of the examples of block oriented are the secondary storage disks and the USBs. In case of stream oriented, the data is transferred in and outside the buffer as a contiguous streams of bytes. So it continuously transfers the data byte by byte, such as terminals, printers, those use the technique of stream oriented device. This is the diagram which shows when there is no buffer allotted by the operating system for the input output device, then how the data is accessed for the execution of a user process. So the input output device directly sends the data to the main memory whenever the user process has to be executed by the CPU on demand. So no storage is provided. Whenever it is needed, directly it has to be loaded into the main memory and to be used. But in case of buffers is provided by the operating system, then the input output device can transfer the data into the buffer provided by the operating system before the request is made by the CPU to execute a user process. So the data is readily available. Once when the CPU needs the data for execution, then the data can be moved to the certain frames in the main memory, or directly it can be provided to the CPU for execution of user process. When the operating system provides single buffer for the process to read its block ahead before the request was made, then the first block is loaded into the buffer. Once the transfer of the first block is complete, then that block is moved on to the certain frames allocated for that process in the main memory, which is termed as the user space in the main memory, and then the process requests to transfer for the second block into the buffer. In this way, the blocks needed for execution are read ahead and stored in the buffer. So this process speeds up the execution of the CPU so that the response time will be reduced and the throughput will be increased. But there are certain disadvantages on buffer. Other than performing the swap in and swapping out of frames and pages from the main memory, this buffering concept complicates the design of operating system to prefetch the data and store it in a buffer, and hence it's an additional overload for the operating system. As we already discussed, stream-oriented buffering is nothing but transferring the data in and out in terms of continuous streams. Specifically speaking, streams in the sense one line at a time is read and stored in the buffer, and one line at a time is again transferred out from the buffer. So in order to indicate the end of each line, a signal called as carriage return is specified at every end of the line. So on seeing the carriage signal, the devices and the hardwares which utilize this data understood that this is the end of every line. There was a problem with allocation of single buffer by the operating system to the process. Just consider a situation of the operating system has to do page replacement, that is, swapping in and out of certain pages from the main memory, and meanwhile certain process has to transfer the data in and out of the buffer. Both the process depends on disk read and write. When both the operating system and also the process to do buffering both are depending upon the disk read write operation, then the disk read write is overloaded there, so that a big queue is formed to perform disk read and write. Because of that, both the operating system and also the process doing buffering both has to wait till their turn comes. So in order to avoid this problem, a concept called as doubling or buffer swapping is introduced. In this case, the operating system provides two buffers for the process. One buffer is used by the process to swap in and out the block or the stream of data from the secondary storage, and the other buffer is used by the operating system to move the blocks or the streams into certain frames into the user process. Even in case of double buffering, when the process try to speed up or rush up the data into the buffer, then there is a delay in buffering due to unavailable of space. So n number of buffers are allocated by the operating system for the process, which can be used for both reading the data into the buffer, and also the operating system can move the data into the user process space. So this type of buffer is defined as circular buffer, since the process and the operating system can read or write into the buffer from the first buffer to the last buffer, then again it can restart the process from the first buffer.